Hello everyone, I'm SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we'll be discussing about computer organization and architecture.
This is what the execution phase of the instruction. The example being given as that is R1 content should be added to R2 and that has to be stored in the R3 register. And how the execution flow will get for this execution of this set of instructions. So let me discuss on this. So that is ALU is nothing but it is going to does the arithmetic and the logic units, logic operations. Okay, so it has this ALU has a two internal register, that is A and B. Whatever the data being copied to this ALU, so it is going to add in terms of content of A and B, and that is going to be stored in case of it is addition operation. So one of the operand, how it is being copied, one of the operand being copied to the A register, one of the operand to be copied to the B register. So how this is getting copied? You are able to see there are register, n number of register being connected. So here we are using which is the register R1 and the R2. So the content, let us first consider R1 is out and that is to be stored in the Y in. That is R1, the content of R1, consider this is R1 register. Now R1 out is going to be activated, that is going to be feed to the internal processor bus. Those content are going to be copied as the Y register. From the Y register being given to the multiplexer. So from the multiplexer, the multiplexer is going to be select. This is the outcome from the Y register being copied to the A register of the ALU. Now what is the content of how it is getting copied? So here you are able to see the R2 is out. When R2 is going to be out, the content is going to be copied and that is being sent via the internal processor bus. From the internal processor bus to being copied to the register B. Now the content of A is from Y and the content of B through the internal bus of the processor. Now what is ALU does? ALU is going to be doing the addition operation where the result being copied, the result being copied to the Z register. So how many control signals does it generate? If ALU is going to perform 8 operations, then the control signal has to be 3. It is going to generate the 3 control signals. Okay, what is the step 1 content here? Step 1, the output of the register R1 and the input of the register Y are enabled and causing the content of R1 to be transferred over the bus Y. What is the step 2? Step 2, the multiplexer select the signal set to Y and causing the multiplexer to get and the content of register Y to the input A of the ALU. At the same time, the content of R2 are gated to the bus and it is going to be input to the B. So the function performed by the ALU depends on the signal supplied to its control signal. In this case, add line is going to be equal to set to 1 and causing the output of the ALU to be sum of two numbers, that is A and B, and the sum should be loaded into the register Z because of the input control line is going to be activated. So the step 3 is the content of ZP transfer to the register R3. So this last transfer cannot be carried out during the step 2 because only one register output can be transferred to the bus during the any clock cycle. So here that is if such as add, subtract, XOR and so on, some degree of encoding is likely to be used. So if the ALU can be perform 8 different operations, so 3 control signals would be suffixed to specify the required operations. Okay, so this is about execution flow of the instruction. So the next we discuss upon the fetching the word from the memory. So how it is going to fetch the word from the memory? So the fetch word from the memory, the processor has to specify the address of the memory location where this information is stored or request a read operation. Here you are able to see this is the diagram when there are two buses are being connected to the MDR register. So that is one is the memory bus data lines, other one is the internal processor data lines. So it is going to be that is what 4 control signals, that is 4 outputs, in and out here, and an in and out output is going to be connected to the internal bus, processor bus, and in and out signal is going to be connected to the memory database. Now, so this applies whether the information to be fetched and represents an instruction in a programmer or operand specified by an instruction. the processor transferred the required address to the memory address register. So what is the required address? The processor is going to be transfer the MER where the data is located. That has to be read from the memory bus to the MDR register. So whose output is being connected to the address lines of the memory bus. At the same time, the processor uses the control lines of memory bus to indicate that it is for read operation. So one is it is going to send the address, and another one is it is going to send the control signal as the read operation. So when it is requested data are received from the memory, so they are stored in the MDR register. So this is being stored in the MDR register. That time MDR in E is going to be activated. Okay, so now this figure shows the four control signals, that is MDR in, MDR out, MDR out E, and MDR out E in E. Okay, so here that is the, it has the four control signals, that is MDR in and MDR out. The control the connection of the internal bus. It is going to control the connection of the internal bus. So the MDR in E and MDR out E, the control the connection to the external bus. So this is as shown in the figure. That is, this can be easily modified to provide the additional connections. So the 3 input multiplexer can be used with the memory bus data lines connected to the third input. So this input is selected as MDR E in. Okay. Next, that is that the second tri-state controlled by MDR out can be used to connect out the flip-flop to the memory bus. Next, during the memory read operation, the timing of internal processor operations must be coordinated with the response to the address device of the memory bus. So this internal bus should be coordinated with the memory bus here. The cache, that is what one of the example, it is the typical cache will respond to a memory request in one clock cycle. So when the cache is miss occurs, the request is going to be forwarded to the main memory, which is introduces the delay of several clock cycles. So a read or a write request may be intent for the register in a memory mapped devices. So to accommodate such IO registers are not cached, and so even IO register are not, so their access always be the number of clock cycle. To accommodate the variability in the processor time, the processor waits until it receives the indication that requested for read operation it has been completed. So that addressed devices set a signal to 1 indicate that the content of the specified locations we have been read and are available on the data lines of the memory. So for example, so this is the example. You are able to see that the response of time of each memory access varies depending on the cache miss, memory mapped IO or IO mapped IO. To accommodate this, processor waits until it receives the indication from the requested operation has been completed. So the memory function completed signal, that is MFC. Okay, so the addressed device is set the signal to 1 to indicate the content of the specified location that have been read and are available on the data lines. Now, the memory bus, for example, that is the register R1 content, that is this is the executable instruction, that is move R1 comma R2. What is the first step? Is the content of R1. This is going to be indexing the addressing, the memory stored indexing. The content of the R1, the address of the R1 is going to be feed to the memory date address register and start the read operation on the memory bus and wait for the control signal, that is memory function completed response from the memory. So meanwhile, the what processor does, it has been wasting the processor time. So the memory bus is going to be activated. During that time, it is going to increment the program counter. So the next is that it is load the content being read from the R1 register to the specified memory location, that is been read from the loaded to the MDR register. So the MDR from the memory bus. So after this, the content of the MDR is going to be transferred to the R2. So these action may be carried out on the separate steps, but some can be combined to into a single step. Each action can be completed one clock cycle except the action 3 which requires one or more clock cycle depending on the speed of the address of the device. Okay. So for simplicity, let us assume that the next is to the action that is the MER is always available on the address lines of the memory bus. So this in the case of when the processor is in the bus master. So when the new address is loaded into MER, it will appear on the memory bus at the beginning of the next clock cycle. So that is as shown in the figure. In this figure, you are able to see that is MER is going to be here. It is going to be active one. That is MDR is going to be address the location bit specified in the instruction. That is for read operation. Okay, so the read control signal is activated at the same time the MDR is going to be activated. So here that is MER is loaded. So here you are able to see that this is a signal cause the problem interface the circuit to send the read command. So that is MER memory read command to the on the bus. So with this arrangement we have combined actions of 1 and 2. That is the MER, the register content of R1 being loaded to the MER, start the read operation on the memory bus. So in this case, we are combining the step 1 and 2. Okay, next it is the actions of 3 and 4. That is wait for the MFC signal and load the MDR from the memory bus. Now action 3 and 4 can also be combined by activating the MDR in signal. So here you are able to see the MDR in while waiting the response from the memory. Thus the data received from the memory are loaded into data received from the memory as soon as the MDR is been activated. So MDR in is going to be activated. The data is been received from the memory bus and that is going to be transferred to the MDR. So at the end of the clock cycle, the MFC signal is received and the next clock cycle, the MDR out is going to be activated. Here the read in E is going to be activated externally, is transfer external and MDR out is been activated. That is nothing but data being transferred to the data to the register R2. This means that the memory read operation requires 3 steps which can be described by that is R1 out, MER in and the read operation, MDR in E and that is going to complete the memory function completed signal is equal to 1. That time MDR out and the data is going to be stored in the R2 register. So in this figure that is MDR in E is set to 1 for exactly the same period of the read command. So that is the memory read and the subsequent that is the value of the MDR in is explicitly with the understanding that is always is equal to the memory read operation. So here you are writing the word into a memory locations follow the similar procedure. The desired address of MER, then the data to be returned to the MDR, return or loaded into the MDR and the write command is issued. Instead of MR command, here the MW command is going to be issued. That is move the content of R1 to the content of R2 to the memory location specified by the R1 register. So requires the following sequences, that is R1 out, MER in. This operation is for write, that is so here is for the write operation. You are able to see earlier we discussed about the read operation from the memory. Writing a word into a memory location follows the similar procedure. So the desired address is loaded into the MER register from R1 out to MER in register. So here the R2 out, the data content is stored in the R2 should be moved to the that particular memory location. So for that reason, the data to be written into the MDR and the write command is going to be issued. The data to be written into the MDR, that is R2 data will be copied to the MDR in register and the write is going to be write operation is control signal is going to be generated. So now that is a move R1 comma R2 comma R1 requires the following sequences, that is R1 out comma MER in, R2 out comma MDR in, write and the MDR out E comma WMFC. So as is in the case of read operation, the write control signals causes the memory bus to interface hardware, issue or write command on the memory bus. So the processor remains in the step until the memory operation is completed and the MFC is received. So this is regarding the storing the word in the memory and how to execute the fetching the word from the memory, and the simple arithmetic, that is performing an arithmetic and the logic operations. Thank you.